Hi class, welcome to lesson 29, the first lesson in Unit 5, Chemical Bonding. By the end of this lesson, you should be able to identify whether a bond is being formed or broken based on whether energy is absorbed or released. Distinguish between the three types of bonds and classify a substance as ionic, covalent, or metallic based upon its properties. Let's get started. So the first question you should ask is, what is a bond? A bond is a force of attraction between two atoms. This force of attraction is electrostatic, or between two different charges. It's between the nucleus, which has a positive charge of one atom, and the valence electron, which is negatively charged of another atom. Remember, opposites attract, and only valence electrons participate in chemical bonding. We know during this electrostatic attraction, the more electronegative elements will attract electrons from the less electronegative elements. So here you can see when we form a bond between the atom of sodium and an atom of chlorine, the more electronegative chlorine atom will pull the valence electrons of sodium towards it. But why? Because when sodium gives away its valence electron, and when chlorine gains one more valence electron, together they will obtain stable, low energy, noble gas valence electron configuration, and they will be attracted because of their opposite charges. Remember, atoms achieve a full valence shell of electrons, a stable electron configuration, when they bond. This is because the potential energy of a compound is lower than the potential energy of unbonded elements. Remember, potential energy is positional energy, so the particles will have more positions when they are not bonded than they will when they are bonded and they obtain the same positions together. As a review from Unit 1, forming bonds is called an exothermic process because energy is released. Breaking bonds always requires energy. Always think that when you want to break a bond, you have to break that bond. You have to add energy in order to break the attraction. Breaking bonds is an endothermic process because energy must be added to the reactants to produce the unbonded products. Can you identify whether or not a bond is broken or formed based on energy being absorbed or released? There are three major types of bonds: covalent, ionic, and metallic. Here is a very important chart that you should copy into your notes. So pause the video and copy down the properties of the ionic, covalent, and metallic bonds. Do not take a screenshot. Make sure you're actually writing this down. You have to know all of this information, and writing it down will be your first step in helping you learn this information. We will refer back to this chart in every lesson in Unit 5. I know that was a lot to write down, but you'll be thankful you wrote. I know that was a lot to write down, but you will be thankful you copied that important chart down for the rest of the lessons in Unit 5. Ionic bonds are formed when electrons are transferred from a metal to a nonmetal. This is due to the fact that there is a very large difference in electronegativity. Metals have low electronegativity, while nonmetals have very high electronegativity.
You already know that atoms gain or lose electrons to form ions in order to obtain stable noble gas valence electron configuration. But when you look at the noble gases in group 18 on the periodic table, you'll notice that not only do they have electron configurations that typically end in 8, but they also have a total charge of 0. When ions combine to form bonds, it is important to make sure that matter is not created or destroyed, that the number of electrons lost by the metal does not exceed the number of electrons gained by the nonmetal. So the total charge must be 0. Look at the first example, calcium chloride. Calcium has a +2 charge, and it must combine with 2 chlorines of a -1 charge, so that together their total charge is 0. You can see here in the chart to the right a few more examples of how elements will combine in compounds to have a total charge of 0. So again, notice that since barium and oxygen have equal but opposite charge, you only require one of each of them in barium oxide. But since potassium has a +1 charge by losing 1 electron, but sulfur has a -2 charge by gaining 2 electrons, you must have 2 potassiums bond with every 1 sulfur so that the total charge is 0.
Because of the strong attraction formed between ions in an ionic compounds form hard crystalline structures with very high melting points and boiling points. The charged nature of ionic compounds allows them to mostly be soluble in water. When ionic compounds dissolve in water, they are able to conduct electricity. When ionic compounds dissolve in water and conduct electricity, we call them electrolytes. Ionic compounds in the solid state have their oppositely charged ions vibrating in a fixed position, so they cannot conduct electricity in the solid state. But in the aqueous state, the ions will separate and be free-flowing, so that in water, ionic compounds become electrolytes and conduct electricity. So here in this graphic, you can see a couple of interesting things. First, water is not ionic because hydrogen is not a metal and oxygen is not a metal. Water does not conduct electricity. Solid ionic compounds do not conduct electricity either because they do not have free-flowing charges. But when we look at the image to the right, you can see that when dissolved in water, the ions of the ionic compounds will be free to move. Free-moving charges will allow for the particles to conduct electricity when dissolved in water. Covalent compounds form when electrons are shared between 2 nonmetals. Electrons are shared because 2 nonmetals will have very similar electronegativities. Covalent compounds are also called molecular substances. Covalent compounds tend to have low melting points and boiling points because they have weak intermolecular forces. Covalent compounds do not conduct electricity under any circumstances.
The difference of electronegativity helps determine the physical properties that a bond will have. The smaller the difference of electronegativity, the more covalent character a bond will have. So that small differences in electronegativity will have low melting points, low boiling points, and softer textures, while the larger the difference of electronegativity, the more ionic the character, meaning the harder the substance with the higher the boiling point.
Metallic bonds have very interesting formulas because they are bonds that form between atoms of the same element. So any metal formula contains metallic bonds. For instance, when we see this metal formula for gold, Au, this will contain metallic bonds in its elemental state. Metallic bonds have relatively high melting points and boiling points, and they are always able to conduct electricity because they have free moving ions. They have a sea as an ocean of mobile electrons. You can see how all the metals delocalize their electrons and they swim around all the metal atoms. Moving electrons or moving charges is what allows electricity to be conducted. Metals always conduct electricity. Now you should be able to distinguish between the three types of bonds and classify a substance as ionic, covalent, or metallic by using the chart you copied down. Eventually you'll learn to memorize all the properties of ionic, covalent, and metallic bonds, but for now you can use your chart to guide you. This concludes lesson number 29, Bonding Basics. Make sure you've taken good notes. Write down any questions you have and bring them to class. Complete your homework on Google Classroom and put your Regents Chemistry reference table and calculator back in your backpack so you are prepared for class. I'll see you soon.